Okay, let's go over our Unit 13 Radicals review. On number 1 here, when I see a really large number like this, and I'm not certain what perfect square goes into it and how many times, I'll just go ahead and just see if I can actually take the square root of 576 and get a nice, neat whole number. And you do. It's 24. So I don't even bother breaking it down and seeing what goes in there and how many times. So if it's a really large number, I'll see if I can actually take the square root of it first, and then I go on from there. Okay, number 2. Square root of 108. So likewise, I could put that in the calculator and see if it gives you a whole number. And just to show you, the square root of 108 does not. It gives you a decimal answer. So this is when I try to break it down. I try to find the largest perfect square that goes in and how many times. And it's 36 goes in there 3 times. And then the square root of 36 comes out to be a nice, pretty little 6. And you can't take the square root of 3, so that recopies. Okay, number 3. I'm going to try to break down the square root of 45. So 9 is the perfect square that goes in there, and it goes in 5 times. The square root of 9 is the perfect square, so this is the one I can take the square root of. The square root of 9 is a pretty little 3. You can't take the square root of 5, so that just recopies. And then the 4 just drops down and multiplies with the 3, and that makes 12 square root of 5. Okay, number 4. I'm trying to add here. So in order to add, you have to have the same number under the radical. And as long as you do have the same number underneath, the only thing you'll actually add are the outside numbers. And negative 3 plus 5 is 2. And then the square root of 13 just recopies. Okay, number 5. I know that 25 is a perfect square, so the square root of 25 is a pretty little 5. The square root of 324, that one I'm not so certain about, so I'm just going to try it. Square root of 324, that's a pretty little 18. So minus 18. And then I can combine like terms and get a negative 23. Okay, number 6. I'm trying to subtract. As long as I have the same number under the radical, I am allowed to subtract. The only thing I actually work out are those outside numbers. Negative 4 minus 2 is negative 6, and the square root of 5 just recopies. How are you looking so far? Everything looking good? Okay, let's look at number 7. All right, this time I'm trying to subtract, but I can't subtract the way it is because I don't have the same numbers underneath the radicals. So I'm going to try to break the square root of 27 down, and I'm going to try to break the square root of 75 down. So let's look at the square root of 27 first. 9 is the perfect square that goes in there, and it goes in there 3 times. 9's the perfect square, so this is the one I can take the square root of and get something nice. The square root of 9 is 3. And then you can't take the square root of 3, so that recopies. The 6 that's in the front, it just drops down, and then it's going to multiply with the 3. So that's going to make 18 square root of 3. Okay, now trying to break down the 75. 25 is the perfect square that goes in, and it goes in 3 times. 25 is the perfect square, so this is the one I can take the square root of. The square root of 25 is 5. I can't take the square root of 3, so that just recopies. The negative 7 that was in the front, I drop it, and I multiply with the 5 to get negative 35. Now that I have the same number underneath the radical, I just work the outside numbers. So I'm going to calculate what 18 minus 35 is, and 18 minus 35 is negative 17, and the square root of 3 just recopies. Okay, number 8. Okay, as of right now, I cannot add these because they don't have the same number under the radical. So then I look to see if I can break down the square root of 11, and that cannot be broken down, so that part just recopies. The square root of 121, though, that is a perfect square. So that comes out nice and neat. And the square root of 121 is just an 11. And this is actually all I can do. This doesn't have a square root of 11 behind it, so I can't actually add these together. So that's as good as it gets. Okay, number 9. We're multiplying now. So when I multiply, I start by multiplying the outside numbers. So I'll multiply the 6 times the negative 2, and that makes negative 12. Then I multiply the square roots. Square root of 7 times square root of 35 is square root of 245. This is when I look to see, just because it's such a large number, if I can take the square root of 245 and get something nice. And let's look. And I can't. So this is when I start breaking it down. I try to figure out what perfect square that goes in there. Does 4 go in there? No. Does 9 go in there? No. Does 16 go in there? No. And I just keep going. Does 25 go in there? No. And if you go far enough, you're going to find that 49 is a perfect square that goes in there. And it goes in there 5 times. Just to show you. 49 goes in there 5 times. The square root of 49, that's the perfect square. Excuse me. The square root of 49 is a pretty little 7. You can't take the square root of 5, so that recopies. The negative 12 drops down. You multiply the negative 12 and 7, and that makes negative 84 square root of 5. Okay, number 10. All right, these I'm multiplying as well. So first I multiply my outside numbers, and this has got a negative 1 in front of it. You just don't see it here. So first I'm going to multiply the 6 and negative 1, and that makes, oh, actually, I'm going to do this problem differently than that this time. And the only reason I'm going to do it differently than 9 is that I see that the square root of 9 is actually a perfect square. It's going to come out nice and neat. And the square root of 64 is a perfect square, so it's going to come out nice and neat. So I'm going to do this different. The square root of 9 is just a pretty little 3, so I'm going to multiply the 6 and the 3 and get an 18. The square root of 64 is just a pretty little 8, so I'm going to take the negative 1 that's in front times 8, which is negative 8. And then I just bring that down, and then I multiply the 18 and the negative 8, and that makes a negative 144. Now I could have done this like the one up above, like number 9. I could have multiplied the 6 and negative 1 and then multiplied the 9 and the 64. I could have done that. I just happened to notice that those were perfect squares and they were going to come out nice and pretty, so might as well just make them come out nice and pretty. Alright, let's look at 11. Alright, number 11. I can see those are not perfect squares, so I'm going to do what I started to talk about just a second ago. This is a negative 1 in front. So first I'm going to multiply the outside numbers, the negative 1 and the 3. So negative 1 times 3 is negative 3. Then I'm going to multiply the square roots. Square root of 8 times square root of 3 is square root of 24. And then I'm going to try to break down my square root of 24. And its 4 goes in there 6 times. Working it out, it should look like this. I got to answer this call. Yes, ma'am. Hey. Maybe. Give me about 10 minutes. I'm recording the review, and then I'll... It's okay. Don't worry about it. It's okay. I'll come down in just a little bit. Okay, bye. Okay, sorry about that. So the square root of 4, that's the perfect square. So the square root of 4 is 2. The square root of 6, you can't take the square root of that, so that recopies. The negative 3 drops and multiplies, and you get negative 6, square root of 6. Okay, looking at number 12. I'm going to start off by writing this twice. And then I'm going to multiply my outside numbers. So 6 times 6 is 36. And then I'm going to multiply my square roots. Square root of 5 times square root of 5 is square root of 25. But what's the square root of 25? Just a 5. Remember, if you multiply by 2 of the same thing under the radical, then shoop, out he comes. And then I can multiply my 36 and 5 and get 180. Okay, let's move on. Now we get into the fun stuff. So number 13. This is about Pythagorean theorem. A squared plus b squared is c squared. I know you don't see a right angle there, but there should technically be a right angle right here. The side across from the right angle, that's your hypotenuse, called the c. The other two sides are your a and your b, and it doesn't matter which one's which. So I have 6 squared plus 6 squared is x squared. 6 squared is 36. Since these are like terms and they're on the left side of the equals, I can combine them. 36 plus 36 is 72. And then to get rid of this squared, I'm going to square root both sides. So if I square root both sides, I'm left with just x on the right and the square root of 72 on the left. And then you can't take the square root of 72 and get a nice, neat whole number, so I'm going to try to break it down. What perfect square goes in there? How many times does it go in there? And that gives me a final answer of 6 square root of 2. Okay, number 14. This is Pythagorean theorem as well. So a squared plus b squared is c squared. They tell me what a is. They tell me what b is. No, they do not tell me what b is, and they tell me what c is. So I just start plugging in what they tell me. A is 8, so I put 8 into the a. B, I don't know. C is 12, so I put 12 into the c. And then I calculate 8 squared is 64. 12 squared is 144. If I want to get b by itself, I have to move this 64, so I'm going to subtract 64 from both sides. If I do that, I will get b squared is 80. To get rid of the squared, I square root both sides. This just gives you a b on the left and square root of 80 on the right. The square root of 80 doesn't come out nice and neat, so I'm going to break it down. And 16 goes in there 5 times. The square root of 16 is 4. You can't take the square root of 5. So that just stays. Okay, 15. This is our distance formula problem. And I'm just going to go ahead and write the formula down for us. This is where we subtract the x's, square that, plus subtract the y's and square that. Remember that x's are these first numbers here. So it should go something like this. 3 minus 1 in parentheses, close it up, square it. Then we subtract the y's. Negative 7 minus 7, close it up and square it. Then I just work out what's in the parentheses. So 3 minus 1 makes 2. Negative 7 minus 7 makes negative 14. 2 squared makes a 4. Negative 14 squared makes a 196. Next thing I have to do is add those numbers, which makes 200. And then I just try to break down my square root of 200. And 100 is the perfect square that goes in, and it goes in twice. And that makes 10 square root of 2. Okay, I'm going to do the same thing with this problem over here. I just have to know what the h and the d are. So h is the ordered pair negative 3, 6. D is the ordered pair negative 2, 4. And I just do what the formula tells me. I subtract the x's, negative 2 minus negative 3. But because I subtract a negative, that makes a plus. 4 minus 6. That stays a minus because I wasn't subtracting a negative number. And then I work out the parentheses. Negative 2 plus 3 makes 1. 4 minus 6 makes negative 2. 1 squared is 1. Negative 2 squared is 4. I add my numbers and get 5, so the distance is the square root of 5. And that doesn't break down anymore, so that's our answer. Okay, next one, same thing. I just needed to know what my F ordered pair is and what my B ordered pair is. And so the ordered pair for F is 3, 5. And the ordered pair for B is 5, -1. And then it's just time to follow the distance formula and do exactly what it says. So first I subtract the x's. 5 minus 3, close it up, square it. -1 minus 5, close it up, square it. Okay, next thing I do is work out what's in the parentheses. So 5 minus 3 is 2. -1 minus 5 is -6. 2 squared makes 4. -6 squared makes 36. If I add those together, I get 40. And then I just break down the 40. 4 goes in there 10 times. The square root of 4 is 2, and you can't take the square root of 10. Okay, number 17. This is a quadratic, and I am going to solve this with the quadratic formula. So quadratic formula, we should just sing that. X equals the opposite of B plus or minus square root B squared minus 4AC all over 2A. So the thing about the quadratic formula, it has to say equals 0, which it does, so we're good to go. So first thing I always do is I identify my A, my B, and my C. I can't help it, I just have to do this. So my A is the number in front of the x squared, so A is 3. My B is the number in front of the x, so B is -8. And my C is the constant, the number without a variable, so the C is a 3. And then I just do what the formula tells me. So let me take you to this step right here. So x equals the opposite of b. I took the opposite of -8 and got a +8, plus or minus square root b squared minus 4ac. Make sure you put parentheses around this, or you will get a wrong answer if you type it in the calculator without parentheses. If I calculate all of this underneath the square root, I will get 28. And I'm just going to show that to you real quick, because I still have some students that struggle with that. So I'm going to go parenthesis, -8, close the parenthesis, squared. This is a minus sign, so minus 4, parenthesis 3, parenthesis 3, and you can see it's 28. Okay, at this point I try to break down the 28, and I actually did that over here. So 4 is the perfect square that goes in. It goes in 7 times. The square root of 4 is 2, and then you can't take the square root of 7, so that recopies. So I'm going to replace the square root of 28 with 2 square root of 7. So that's what I did right there. Okay, at this point I ignore what's under the square root, and I look to see if I can divide these 3 numbers all by the same something. And I can divide all of these by 2. So this would be your final answer. 8 divided by 2 is 4. 2 divided by 2 is 1. And I can put that 1 there. I just don't have to. The square root just always recopies no matter what. And 6 divided by 2 is 3. Okay, next one. This is a quadratic as well. I just need to make sure it says equals 0, because it does not right now. So I subtract 3 from both sides. Then I have to make sure it's in order. And remember, it goes x squared, then x, then constant. Okay, at this point, a is the number in front of the x squared, b's the number in front of the x, so b is 7, and c is the constant, c is the -3. And I'm just going to show it to you. And you cannot take the square root of 73 and get anything pretty, any whole numbers. And there's no perfect square that goes into 73, so I just leave it like that. And that's the most exact answer that I can possibly get. I think you guys will do great on your test. Smiley face.